My name is Craig Batten. I'm the founding director of Certified Energy Solutions. Certified Energy Solutions was formed to provide both on and off-grid energy systems for both residential, commercial. We're based in Gympie, and we do specialise in the off-grid area and install a lot of projects around Queensland. Daniel Winkler, my co-director. Daniel is in charge of our technical and installation side of the business, and if anyone wants to know anything about off-grid living, Dan's the man. So I'm going to pass you over to Dan, and you can direct your questions to Dan the man.
So I'm the geek. Pretty much, the technical. So I suppose we don't want to make this a sales thing for everyone, so what I want to do is do a bit of an interactive process where you guys can ask questions, and we can respond back with answers. So yeah, it is a little quiet, isn't it? There we go. I'm used to being on the stage. He's used to being on the stage. Yeah, he's got the presence. There we go. Thanks, mate. All right, so let's roll off some questions, guys. Hit me up. Yep. Okay. Let's roll off some questions, guys. Yes, they are. Yep, they are. We do have some sleep in a workshop that's got a lathe, a welder, a car hoist, all this stuff. We just had a situation with a customer out at Canungra where basically it's their second system they got with us for another property, a development. And basically we did the low profile and we sized the system appropriately. And then she called me the other day and she goes, I'm at the pool shop. I said, Cass, why are you at the pool shop? She goes, oh, I'm putting in a spa. I went, oh. And she goes, can the off-grid system run it? And I said, well, I did oversize your system. And I said, but I need to talk to the pool, the tech there. So you get on the phone and he goes, look, it's going to pull 500 watts continuously for a 24-hour period. So all of a sudden, you look at this massive draw that's adding to both the peak load, but also the battery capacity, discharge, the storage capacity. And you've got to make sure you can account for that. Luckily, when we do off-grid systems, if you've got a realistic budget for the system, we can oversize the system to start so you can have those surprises pop in. So the answer there was yes, Cash, you can have a spa. And no, the generator's not going to run 24/7. So, always oversize your system. Never design a system where it's hitting peak, because if you hit peak in your system, if you design, say, an off-grid solution that's got 5,000 watts of output, what you've got to keep in mind is you turn on a microwave, there's 2,000 watts out of your 5,000 watts headroom. You turn on a kettle, 1,500 watts out of that 5,000 watt headroom. You turn on a couple of electric hot plates, you're adding another couple of thousand watts. And then you flush the toilet, generator fires up. So you're going to hit that peak, and that's where you kind of bounce it. We've had customers that come in, they say, look, we've got a $30,000 budget, we want an off-grid system to run aircon, we want to run an electric cooktop, not gas, we want an electric hot water system, and we'll go on to that in a minute. And this is our budget. And you go, okay, well, just so you know, you're probably going to have a 30% runtime of your generator on days where your solar might be struggling, because you don't have enough battery capacity, you don't have enough budget for an oversized system. And you catch up with them 2 months later and they go, the generators are fired up once. And it's like, well, how'd that happen? And then the wife might go, I've been chasing hubby around with a stick and tell him to turn stuff on when I turn something on. So you can manage it as long as you can design a system so you can use it like the grid, but that obviously turns into dollars as far as the hardware you need. Or you can go for a smaller investment and basically manage your power consumption and be aware of how these devices consume. And things like energy efficiency, we touched on that before. Electric hot water systems, if you are going to go for electric hot water, go for a heat pump. They're going to be about 70% less power draw compared to a conventional electric hot water system. So they're going to consume a lot less, and then you don't have to worry about gas services. The perfect situation, I've noticed a lot of these tiny homes around here are using gas services, so gas, hot water, gas cooking. That's perfect. It's absolutely spot on. So that's definitely a better way to go around it for off-grid. And we get a lot of customers that approach us and say, look, we're building, what do we do? LED lighting, gas, hot water, gas cooking, you can run your air conditioning systems, and even all your appliances inside the house, and you can use power as you need it. And then you've always got that backup device of the generator for the odd occasion that you might have a heap of people around, you're entertaining, you're using more power at the same time than you normally do. The generator's there as basically an additional assistant.
I consider these systems to be very, very self-sufficient.
Yep.
But what about when it comes to the impact of one of these small welder?
Yeah, perfectly fine. Yep.
If you had a 10,000 10 kilowatt storage tank,
Yeah.
and you got your solar and everything, and you still use the welder on that system?
Definitely, without a drama.
There's not a peak loads on that.
Yeah, but you're inverted, like most welders now. If we're talking about like an old arc welder, it's a massive, copper transformer style welder, they're going to draw a lot of amps on startup. That's where the amps come in.
Yeah, exactly. They're inverter technology, so they've got a soft start.
I was interested in the electronics of the inverter and everything.
Yeah,
Being
yep.
able to handle the actual
Yep.
big loads.
Yeah, yeah.
I was worried about the transistor being overloaded.
No, perfectly fine. So we have a lot of customers that basically they might start off with the shed house and then they use the off-grid system to build a house. And they start off obviously with smaller battery capacity and solar, and as they kind of evolve that property and the load profile, they just simply add to the system to build up the cope with the demands. But you can have a 5,000 watt off-grid inverter that's going to handle the world at any day of the week perfectly fine. And if you use it through the day, it will utilise the solar panels instead of your battery system. So the batteries are only ever there just for that kind of overcast. Like today, we've got an off-grid system at our stand over there. It's got 10,000 watts of inverter, we've got a large battery bank and a 4 kilowatt array, obviously with the foot space limitation that we've got, square meterage. Now, that system there is sitting there at 100%. We're only drawing a baseline of about 300 to 400 watts continuously over there with the fridges and TVs and computers and stuff plugged in. So, you know, essentially everything's going to run today, even on an overcast day, off that solar system. And then the batteries will step in to help the solar in a situation where, say, for example, your load's 5,000 watts. At the moment, you've got all these devices running, you've got a 5,000 watt load you're pulling from the system, and the solar might only be hitting 2,000 watts. The balance of 3 will then come from the battery, and then as soon as that load stops or reduces, the battery system will then stop discharging, the solar will take back over, and it'll start force charging your battery. So the system's always going to focus on self-consumption first, and then basically supplement that self-consumption by recharging the battery and making sure it's at 100%. So that's how that kind of chain works in that process. Biggest difference with off-grid compared to standard solar that you might have at your residential houses is your standard solar system will basically cover your consumption load but also export power back to the grid. In an off-grid situation, there's nowhere for that power to go, which isn't a bad thing these days because you get nothing for it anyway when you send it back. But what will happen is the solar will actually ramp down because it's got nowhere else to go. If the energy load's covered through the day and the battery system's full, it'll literally ramp down to reduce heat in the system to make it more efficient. So, and then once the load picks up, the solar will actually go, do we have enough generation here to cover the load? And then you'll actually see the PV, the photovoltaic, wattage in that monitoring jump straight back up to cover the load. So it's always responding to what you're doing inside the house.
A little bit closer, that's all. That question? Yeah.
Yep.
For a backup Jenny, the
Yeah.
48 volt system, do you need any special specs on it, or can you just
Yes.
hook up any Jenny? Or
Good question. So most systems are automated these days. So essentially, if you look for a generator, it's got a 2-wire start integration, so it can be automatically integrated with a signal switch. That's pretty much all you need to look for. Obviously, if you've got a single phase or a 3-phase system, they both utilise 48 volt batteries hooked up in series, or even in parallel, depending on the off-grid system. So you've just got to stick with a single phase generator for a single phase system and 3-phase to 3-phase. That's all you need to know. You generally want to make sure your generator is oversized about 30 to 40% above what your inverter capacity is. Yep. So
you just charge them back through your the MPP controller, or you?
well, yeah, so it runs through the inverter. So every single system, even the modular off-grid systems, they control the charge and the discharge of the battery system, but also the integration of the generator on the backup service. So essentially that's the device that's going to tell it how much to put out, but it'll also integrate as a load assist device as well as a backup device. So if you're in a situation where you have a component fail, it'll automatically fire up the generator, keep power going, which is why every off-grid system, even though the majority of the product is extremely reliable, you have to have a contingency. But it'll also work for poor weather events like PV performance days, things like that. It'll assist the system to get you through. Yep. Good question. Yes. Yep. Oh, still cut. Yep.
At some point, could you start from the beginning? Because
Yeah.
technology
Yep.
I'm not familiar with. I'm looking
Yeah.
at creating a tiny home.
Yeah, cool.
And
Yep.
there's words being bandied around. I don't even know what they mean, so
Yeah.
I can't even evaluate the
That's spot on. Spot on. So
information.
let's go over a little bit of terminology when you're talking to any retailer or any consultant about off-grid power solutions. So two of the big important things you need to keep in mind is kilowatts and kilowatt hours. They're the two biggest terminologies you need to understand when you're picking the right size system. So kilowatt is essentially the inverter capacity, how much power that can put out at any one point. So think of a tacho gauge in a car. If you've got a 7,000 RPM red line, that inverter, if it's got 7 kilowatts or 7,000 watts, will only be able to put out 7,000 watts of power. So that's where you need to understand what electrical devices you're running inside the house. If you're going to be running air conditioning, electric hot water, electric cooking, all those devices added up at the same time will give you your peak output. So that's probably the load analysis. So when you're talking to a consultancy company that's doing off-grid or specialising in that field, they'll actually sit down and find out what devices you're going to run, when you're going to run them, how long you're going to run them for, and that'll give you an indication of what your kilowatt requirement is for your peak loads or even your surge ratings. So the second term will be kilowatt hours. Think of it like a fuel tank in a car. So essentially, if you've got a long-range tank in the car, it means you can go longer with needing, smaller solar input or lack of generator input because you've got enough storage in the tank to get you through between the fuel stops. That's where your kilowatt hours or your battery capacity comes into play. So it also comes down to nighttime and daytime usage. If you use a lot of your power through the night, it's going to be a more expensive off-grid system because you need enough kilowatt hour in capacity to get you through that period until the sun comes up. So the most cost-effective way of doing an off-grid power solution is to use as much power as you can through the day and have your basic services through the night. Yep.